Hi, I wanted to go over a couple of things that I promised you that I would go over. One thing I wanted to review with you is a 2 by 2 inverse, which you will be responsible in finding without a calculator, okay? So without a calculator, let's find the inverse of matrix A, 3, 4, 1, 2. I told you can use a calculator to actually calculate it, right? And you'll get an inverse matrix of a 2 by 2. You can use a calculator, but you can also do it this way. Ready? So all the actual formula to find the inverse of a 2 by 2 matrix goes something like this. To find the inverse, you take the determinant of A, 1 over that, okay? And you multiply by, you know how normally this position, let's say A, is A, B, C, D. What we do during an inverse is simply we switch A and D. So A and D are switched, right? The positions, and negative C and negative D. So C and D, B and C, sorry about that. B and C are completely opposite. So it used to be a B, now it becomes the opposite of B, and it becomes opposite of C. So for example, in our case, let's first find the determinant because we need the determinant, right? And how do you find the determinant of a 2 by 2 matrix? Easy peasy. You simply take, you find the determinant of, Mr. Paul was looking at me. Sorry, guys. You take the diagonals, right? Remember, it's A and D. So it's determinant, I'll actually write the formula here. Determinant of A is AD minus BC, right? So we do 3 times 2 minus 1 times 4. And what do you get? 6 minus 4, which is 2. But we're not done because we need to find the inverse, right? So what do? So we take the inverse of A, inverse, which is going to be 1 over the determinant of A, and we swap A and D. So this first position, A11, becomes 2. This becomes 3. We opposite the B position, and we opposite the C position. And when we actually multiply the half in, we get 1, negative half, negative 2, and 3 over 2. You know what you should do? Check my answer, guys. When you do A inverse on your calculator, what do you get? You get this. And you know how we can check that answer, right? All we have to do is A inverse. See if we get the identity. Well, let's see. Let's just do it really quickly. 3, 4, 1, 2, and we multiply 1, negative 2, negative half, and 3 over 2. Let's see what we get. Are you ready? I'm going to do the multiplication really fast, okay? Are you ready? All right, hang on tight. 3 times 1 is 3, minus 2 is 1. Uh-oh, we're getting there close, okay? Next one better give me a 0. Are you ready? 3 times half is negative 3 over 2. I'm going to start writing these down. Negative 3 over 2. But what's 1 times 3 over 2? Uh-oh, positive 3 over 2. Ding, 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 0. Next one, 4 times 1 is 4. Times 2 times negative 2, that's a 0. All right, yahoo! Now 4 times half is negative 2, so I'm going to keep track of that. Okay, and then what's so we did 4 times negative half, right? What's 2 times 3 over 2? That's a 3. Positive. Ding, 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 ding. That's a 1. So we did it correctly. So again, this is how you find the inverse of a 2 by 2 matrix without a calculator. All right, moving right along, let me show you how to find the determinant using the minors and cofactor method. This is a little bit of a strange technique, but it's very useful, and it's used for any size matrix. Okay, any size matrix. Here we go. Are you ready? All right. So we chose row 3 because it's the simplest looking. Look how easy it looks, right? And I want to just show you something really quick before we start this. Any kind of M by M matrix, this position is always going to start with a positive, and all the signs have to alternate. So no signs could be touching. So you have to look at the position. So for example, this position here, negative 1. So I'm going to highlight it. This guy here, negative 1. That guy, it goes positive, negative, positive. That means it stays negative because it's a positive. Get it? So positive, negative. This guy, if we were to use this 2 right here, it would have to turn negative. You'll see what I mean. Okay, so here we go. We chose row 3, so we're going to find the determinant of B, in our case, B. Okay, and we chose row A. What do? We use the row that you chose. And the value is -1. That's called a cofactor. And then what we do is we cover up the row and the column. The row and the column, watch my, what is this? Okay, cursor. Row and the column, we cover up the row and the column that the -1 consists of. So we're left with, what's the minor that we're left with? We're left with this guy here, right? So we write that down. +2, 2, -1, -1, 3 is the matrix that we're left with. Okay? I'm going to erase that because it changes every time. I know that seemed a little bit weird, but that's called a minor, okay? Now we go to the next term, next one, 0. But you remember how this guy was a positive? This is a minus. So we're going to put a minus, okay? -0, but a -0 is a little bit weird, right? So, you know what? I'm going to always do a plus, but just put a negative because it's always a plus, but whatever this guy is kind of dictates the sign. And we're going to get a minor here. What's the minor that we're going to achieve? Well, we cover up everything that the 0 is contained of. So all the column and the row that the 0 is that includes a 0. So it's going to be 1, 2, -1, 3. So 1, 2, -1, 3. Let's do that again. This row, this column, and this row contains a 0 that we're looking at. Therefore, it's 1, 2, -1, 3. Okay? All right. Last one. We're left with, remember, this guy is positive. So it's positive, negative, positive. So positive, negative, positive, negative, and positive. So that 1 stays 1 as well. Remember, this is not going to be, you're not responsible in doing this by hand using this method. So I'm going to go plus a +1. And what's the minor, right? What's the minor? Well, let's cover up every row and every column that consists of this 1. So it's going to be 1, 2, 2, -1. 1, 2, 2, -1. And you remember what this symbol means, right? It's the determinant. So what do? We simply calculate now. -1 times, what's the determinant of this 2 by 2 matrix? It's 6 minus a +1. This guy is just a 0 because it has a 0 here, right? So anything, a product of 0 is just 0. +1 times, the determinant of this 2 by 2 is -1 minus a 4. Because it's -1, you cross multiply, right? A, D, B, C, right? So what are we left with? We're left with -1. You better get a -10, right? So it's -5 plus 1 times -5, which equals -10. And our determinants are the same thing. So this is again called minors and cofactors. Obviously, if you were responsible for this, you would need a lot more practice. But don't worry, you'll only be responsible for the diagonal method, okay? All right, make sure you watch the next video for ref and ref. See you later.